Shane, who would present the next socket. So hold on.
Okay, so my name is Shane, and I'm gonna prove that all numbers equal 0. So I'm gonna start. Oh, I'm gonna start by saying that x equals a, and now I'm going to multiply both sides by negative 4a. So now I will have negative 4ax equals negative 4a squared. Next, I'm going to add 4a squared to both sides. So I will have negative 4ax plus 4a squared equals 0. Next, I'm going to add x squared to both sides. So I'll have x squared minus 4ax plus 4a squared, squared equals x squared. Okay. Now, using that formula, I can turn this into a simpler form, which is x minus 2a squared equals x squared. And now I'm going to take the square root of both sides, and I will end up with x minus 2a equals x. And from now on, just to make it simpler, because x and a are equal, I'm going to replace x with a. So this statement would be a minus 2a equals a. And you can simplify that to negative a equals a. And next, I'm going to add a to both sides, and I'll have 0 equals 2a. And now finally, I'm going to divide both sides by 2, and you end up with 0 equals a. So, obviously that's not the case. So I'm going to go through step by step to show you where it went wrong. So this x equals a, that's just a statement. That is correct. The solution here is a, and I multiply that by negative 4a, and I end up with negative 4a squared. That is correct. Next, I add 4a squared, and I get 0. And negative 4a squared plus 4a squared is 0, so that is correct. Next, I add, x squared, and 0 plus x squared equals x squared, so this is correct. This is just this, but in a simpler form, so this is correct. But these two, which are the same, so I'm just going to mark them together, are obviously not correct, because this is where minus 2a equals a. That is obviously not correct. So the issue is between these two. And the problem is that a number, the square root of a number squared is not that original number, which is kind of a mouthful. So I'm going to demonstrate that right here, I guess. So let's say I have -3 squared, and that equals 9. But then I'll take the square root of 9, and I get 3. And what that means, and obviously, -3. Okay, wait. And so, and obviously, -3 is not 3. So, what that proves is that the square root of a number squared does not equal the original number. So right here, okay, so what it does equal, assuming that that number, or it does not necessarily equal the same number. So assuming that that first number is negative, the outcome, if you square it and then take the square root, will be positive. So right here, before it goes wrong, we have x minus 2a, which equals a minus 2a, which equals -a squared, which ends up being a squared. And a squared is positive and also x squared, so this is correct. But when I took the square root of it, this side remained positive, but this side did not change, or this side reverted back to being negative. So this would be correct if it was written as x minus 2a equals -x. And then I can finish that off by saying that that equals a minus 2a equals -a. And then that simplifies to -a equals -a. So that is how to solve this part, but I also am going to prove that every number equals 0 except for 0. Obviously, that's assuming that this logic is correct, but assuming it is, then right here I will explain. So let's say, okay, I'm going to claim that 6 equals 3. This clearly is a false statement. But if I multiply both sides by 0, then it ends up being 0 equals 0. So you end up from a false statement to a true statement, which means that something imbalanced is happening to both sides, which means that you can't do that. Or I mean, like, you can write it out, but it just does not work. So with this logic, and that is used in practice right here, because you multiply by a. So assuming a was 0, then you would be multiplying both sides by 0, which does something imbalanced to both sides. With that same logic, that 0 does something imbalanced, taking the square root of either side, or using an exponent for both sides, or taking the square root of both sides, or using an exponent on both sides, also is an imbalanced equation. So you also can't do that to both sides either.